and welcome back to another day of Advent of Code. I'm excited to see the puzzles maybe get a little bit more difficult, but we'll see how hard the ramp up is from day 2 to day 3. So the puzzle unlocks in about 10 minutes, and with the time until then, I figure I would start learning a little bit about Go generics, because that is why I have GoTip installed. Right, so I'm currently using the latest Go Alpha, although I should check whether I can replace that with Go 118 Beta. But yeah, so I am hoping to get some practical exposure to Go generics in this year's Advent of Code, and I hope you will join me for the ride. So let me go ahead and pop open my Twitch video producer and do all of those wonderful things. Also, there are some great other people who are also streaming, like Where Is X, like Irene's, like Epsilon. So, please make sure you say hi to them. Oh, my stream title is wrong. I should fix that. Let's go and fix that real quick. Definitely a little bit behind the game right now. I just got back from walking the dog. But so it goes. There we go. All right, so where were we? Stream title is updated. No canonical. I would love to use live patch, except for you don't offer live patch for ARM64 yet. All right, let's go ahead and we've got 9 minutes. Let's go ahead and look at the Go 118 beta first. See whether that came out yesterday or like what the status is. Go release dashboard as well as Golang dev. Let's see what's going on over there. Okay, Go 117.4 with a security thing. Nope, there is no news on Go 118. Is there? Here's the query. Okay. The current number of blockers is 7. Okay, that's getting there. That's going to be exciting. And the other thing I should look up is the Golang generics proposal, which was accepted. I think it's located here. And let's also go ahead and update my Go then. Go to download, and we'll go ahead and get it chugging along on that. How was everyone's day? Hello, Lala. Oh, I've been working a little bit intensely. This is kind of how December always is for me, because there's Advent of Code in the evenings, and there's lots of stuff you kind of want to finish up between the end of the year. So that's kind of what I'm up to right now, is polishing up all of the stuff that I want to tidy up before I go on holidays. Awesome. Yeah, always keep an eye on production, especially if you've recently pushed something. In my case, I haven't actually touched production in the past couple of hours because I got off work around 5. So yeah, not much watching. I'm not on call right now. I was on call parts of last week, but not this week. Let's see. I should probably, just in case, log on to my G Suite account off stream. Cool. And looks like I'll have working Go compiler soon. So what do we have here? We have the language proposal process. They've started the process. Okay. Design based on type parameters. Right. So there's the issue. And I presume that if I read the proposal document, okay, so functions can take a parameter in brackets, yep. Types can also take a, oh, interesting, okay. Yeah, I believe that. Oh, I see, and that's why they're using any as a type thing rather than as interface bracket. Okay, yep. Got constraints. So type constraint that permits any type. Okay. Cool. So where is the actual design? Is this the design? This has become a proposal. Great. Ah, there we go. Okay, this is the August proposal. All right, so that's the original thing. So exact, approximate, and union. Cool. Okay, I've been doing a fair bit of TypeScript. The union stuff is perfectly familiar to me. Okay, cool. So right, so that needs to have the interface. Yep, so that's the interface stringer. Yep. So how does the constraint operate? Oh, okay. So you just specify it as if. Okay. Yep. Interface can be a. Okay. Yep. I believe that. That's fine. I think that's reasonable. Generics have been a hotly debated subject in Golang. The language originally released without them and had this like diatribe almost that said, hey, we don't think we need generics. Generics are unnecessarily complicated. In most cases, it's better to just repeat yourself, etc. And over time, as people use the language, they discover that no, there really still is a need for generics in some places. Most notably, I have found a lack of generics painful when using the sync map class, which handles the locking for you when you access a map. And in that case, you have to repeatedly cast to and from the interface / any type, and that is really bad. So it would have been nice for the sync map class to support generics. So that's my particular bugbear with that. And Go 118, which is currently just about, I think we're overdue by a day and a half now on the beta coming out. It's scheduled to release as generally available on February 1st, but obviously you're allowed to preview. In fact, that's what I'm doing right now, whatever the state of the current tip of the development tree is. And that has the support that has been agreed upon in this proposal implemented. Some of the standard library stuff has been updated, but not all of it. So that's basically the that is basically the state of the type parameters and of generics in Golang. Is proposal was accepted as recent and iterated upon as recently as August in our development cycle, and it is just now December, and it is now concluding the development cycle. Okay, so I've done the learning I'm going to do today about Go generics. I at least know how to invoke them, which is good. So let's go ahead and copy this to day 03 Go inputs 3.input, and let's go ahead and fix this up and remove all of the code that was specific to yesterday's puzzle, which is basically from here on down. Oops, for S in range split, and that is basically what we need. Okay. Cool. So I am basically, hi Eric, how are you doing? I was just reading through the Golang 118 generic / type parameters proposal because this copy of Go that I'm using is actually capable of interpreting generics. I just haven't had to use them so far. So using my pre-stream time wisely instead of just sitting there chatting about my day. Although I did chat a little bit about my day. All right, well, we've got a minute until unlock, and let's hope that these server hamsters hold up well. But I guess that now that, the capacity planning from day one has been exercised, day one is always the most stressful of that. So, and yeah, Srujan, I agree. I was around for when Java went to having generics, and it was magical, and it made my life infinitely easier. So I'm curious what the impact is going to be in the Go ecosystem for the same thing. But we'll see. Okay. Just pop open a terminal like this as well, and we're basically ready. So we just have this ready to take the input, and hello, Caster and Tech. Kastner Tech. Nice to meet you. It's really wonderful to see people joining me for these things. Oh, egads. It was originally parentheses. Oh, that's a little disgusting. Yeah. Well, ergonomics are important. I'm guessing that this is going to be another submarine theme, and I am almost wondering whether it's now going to start having us do the kind of turtle moving around, change your angle, go straight, left, right, etc. I bet that's my suspicion as to what's about to happen, but let's find out. See you on the other side. Good luck to everyone. All right, we've got a diagnostic code. Find the most common bit in the corresponding position. Most common bit in each position is, okay, yep, so first bit, second bit, okay, yep. So, and then you calculate it back to decimal. What is the power consumption? Okay, so the least common bit, so it's always going to be precisely the inverse. Okay, great, so I know how to do this. So let's go ahead and get an input. Again, education, not speed is my goal. So that seems fine. That's a list of inputs indeed. So what we're going to do is we're going to make a these are all, I can assume that I can hard code the length of this. That'll just make my life easier. This is 12 characters long. Just double check that. 1, 2, 3, 4, 1, 2, 3, 4. Yep, this is 12 characters long. Okay. Yes, this a bool is not quite as efficient as bit banging, but I really don't want to bit bang. Okay. So, we'll do something like this, and all right, so should probably actually make 12 bool a type, but that's fine. Okay, so AC is rune of, I think I can just do this. Then line of pause is true. Okay. So now, I also happen to know in this case, like, yes, it's helpful to have parsed it, but I could also start calculating the result here as well. So let's go ahead and do that here. So the gamma is the first one. Actually, that's going to be an int. Actually, let's do it this way. So let's keep track of the number of ones seen. All right, so ones of, right. So now I should be able to just run a quick check. So now this should be able to something like this should be able to do the trick. I'm just printing out plenty of debug output for myself as I go. So let's just make sure that that is correct. Okay, yep, I don't use strconv. That's a fair cop. And int 12 is not. Oh, right. There we go. And so this is also wrong. Oh, because I need make. Right, there we go. Oh, and that needs an initial length as well. Okay. And where's count? Oh, count is not. Oh, because it's. There we go. And I don't actually need position here yet. Okay. So let's just check this against the simple value. So the simple value let's just check this and make sure we're exhaustively doing this correct. Make sure I don't have any errors here. So in this case, we have a truncated thing, right? Because it's only 5 digits, but that's fine. 10110. Yep, that looks correct. Okay, cool. All right, so now that I've done that, now I just need to convert that to a. Now I just need to convert this into binary. Great. So let's go ahead and do that. So now I can epsilon is going to be we have epsilon and gamma. They're both integers. So now let's see. So I need to actually reverse iterate this. I need to start from the end rather than from the beginning. And the reason for doing that is okay. So we're going to do it this way. So let's do gamma binary. Again, not necessarily the fastest, but I feel like this is the most logical way to explain it to you all, how I'm doing this. So we have a length 12 of a bool. So epsilon binary pause is going to be true, and gamma binary is false. Oops. And over here, we reverse this. And now, finally, we're going to have pause starts off as 11, pause is greater than or equal to 0, pause minus minus. Okay. Wait, actually, no. There's a fine way to handle this without reversing. Never mind. We're not doing it this way. This way's silly. Okay. So the way that we handle this is for each position. Because we want to shift the bits that I've seen so far up 1. Does that work? Because I'm basically shift mask. Wait, I think I should have actually done it the proper way. Yeah, it's better to always go right to left and left to right. Okay, we're actually doing it the original way. Sorry, folks. Rather do it correctly than take the shortcut. Binary 12 bool. Okay. That defaults to false, so that's fine. Okay. Fortunately, it's very easy to write code that you literally just wrote. So what we do is if epsilon, oh, I can spell epsilon, not to be confused with my friend Epsilon, who is also a streamer. Oh. Now I feel even sillier. I could have done this the right way to begin with. Yeah, that binary math just always loves to throw me off. Okay, there is a way to do this. It's just literally let's see. Forget. Is there a exponentiation operator in Golang? I don't think there is. Yeah, I'd have to use POW, which is annoying. Oh. Yes. That's fine. This makes me deeply, and oh. Does bit shift work in Go? Okay, well, in that case. Yeah, in that case, that makes my life easier. Right. I remember how to do all of these things, I swear. Okay. All right. I think this basically this basically will do it. So something like this should do the trick. And that's going to be epsilon times gamma. All right, and the other thing I'm going to do is I'm going to really quickly, just to make this coherent, no, I can't make this a variable. Okay, that's fine. So let's go ahead and run that. Obviously, this number is going to be wrong because it includes some extra zeros that shouldn't be there. But let's run it on the regular input, which I can actually check because I can actually literally just use Python, right? And I can say, okay, right, let's go ahead and flip all the digits. Right, so if I multiply these two things together, that'll tell me whether my answer works or not, and that does, so therefore my original answer will work as well. So I think that is the power consumption. That's correct. Didn't make top 1000, it's fine. I got stalled on silly binary math stuff. Of course Golang supports bit shifting, otherwise it would be a not very good programming language. Okay, cool. So now we do part 2, the life support rating, the oxygen generator rating, by the CO2 scrubber rating. Filtering out values until only one remains. Start with the full list. Consider just the first bit. Keep only the numbers selected by the bit criteria. Repeat the process considering the next bit to the right. Okay. I see how to do this. Okay, so I'm going to remove my debug output now that I'm confident this works. Let me just do that really fast. Yep, okay, great. So now we're going to solve the part 2. So the oxygen generator reading is the most common value in the current thing. Keep only numbers with that bit in that position. Okay. And the least common, so therefore I can reuse the epsilon and gamma, assuming that I use that I use the bit masking. Okay, cool, that's helpful. Great, so have only one number left. Consider the next bit to the right. Okay, great. So I'm going to do it this way. We've got an oxygen value, and we've got a scrubber value, which are going to be an integer of some kind. And I'm supposed to return the multiplier of both. Okay. I always like writing the thing that I'm supposed to return at the end to remind me of what I'm doing. Okay. We're going to do something like this, and we're going to have to do it twice. Actually, yeah, we're going to have to do each of these things independently. The logic is going to be pretty similar, though. Hello, David West. Thank you for bringing your viewers to me. All right. So let's do this. So consider the first bit. Most common value. We already know what the most common value is because we have the values epsilon and gamma. So if for calculating the oxygen value, what we're going to do is potential oxygen. We're going to make a map that goes from the data position, which is going to be an integer, to a bool. And that way we will flag everything true initially, and then we'll flag everything false. Potential scrubber. All right, so now we can start using the data array. So we're going to set all of these bits to true, and then that way when there's only one left, no, because I want to be able to iterate the map to find only the candidates. Yeah, so all of them start off as candidates, and I delete them as we go, and then once there's only one left, we're good. Okay. Potential oxygen I is true. Potential scrubber I is also true. Okay. So let's see how to do this now. So the bit to match is going to be bit to match is going to be, we need to get epsilon at position, and we're going from left to right. Correct? Yeah. Consider only the first bit, so we're starting from the left bit. Okay, good. So epsilon, it's been that's been shifted by 11, or 11 minus pause. So if for I line range data, if line of pause equals bit to match, then line of, there's no way I'm making the top 1,000 today. I'm just too rusty with my bit banging. It happens. If line of pause is not bit to match, then we're going to remove it from consideration. So how do we do that? In order to remove it from consideration, wait a second. This is just prefix matching, actually. Yeah, this is literally just prefix matching, right? Like, if this value here is supposed to be if 10110, right? Then we're looking for everything here that has a prefix of 1011, and then at that point there is there are an equal number. Wait, equal number? The fifth position. Full list of numbers. Oh, no, that doesn't work. The reason that doesn't work is that I have to use this is, does it use the list so far? Yeah, I think it uses the most common in the list so far. Annoying. Sad face. Okay, so I cannot use epsilon. Shit. Okay. So I need to... Yeah, okay. That is unfortunate. Have I tried piping my input into Kafka? I mean, I can use Kafka Cat, but it's just going to sit there and nothing's going to consume it. That's not going to help me. Okay, darn, I was hoping that this was actually going to be easier than it was. Okay, this is why you read the problem, and this is why it is not just simply prefix matching. Great. That is... Okay, so that's fine. Okay, so... Okay, so now I understand what I have to do. Okay, so we have to do a double iteration. So we're going to do it this way. All right, so okay, so that's fine. I know how to do this now. Okay. Candidates is going to be length of potential oxygen. If candidates is 1, then this is our value. Then we just need to okay, I understand how to do this. This is completely workable, and yes, decomposing into multiple functions would help, but I kind of I will I will solve that problem later. Okay, for pause set, if set, then potential, then decision equals, great. And then finally, we're going to break out of here. Okay. Yep, and that will break out of this for loop, which is what we want to do. Cool. Otherwise, we need to iterate to get all of the indices. And now, wait, potential oxygen, actually no, this is, oh, right. Yep, that's fine, that's fine. Yeah, because I don't want to copy around bits quite as much, so that's okay. I called it data above. Yeah, I called it data. Okay. So let's just actually change this to IDX to make that clear what's going on. Okay. So I need to not mix up P and pause here, but that's fine. All right. Oh, wait. I don't care about iterating all of them, actually, because... Right. Okay. So... let's go ahead and... Okay. So one count is 0. Data IDX pause. There we go. Okay. I understand how to do this now. Yep, there is a little bit, just a little bit of a difficulty curve, but not too bad. Okay, so if one is, if 0 and 1 are equally common, keep values with a 1 in the position being considered. Okay. So now, yep, all right, I think that should do it. I forget how iterating, are you allowed to delete from a map while iterating? Yes, this is safe. Yeah, okay, great. All right, so that should do the trick here, and I'm going to do the super ugly thing, and I'm going to repeat myself even though it makes me sad. Potential scrubber. Scrubber, okay. And now the same thing, except for now we're looking for the least common one. And if they are the same, I want to return false. So that's correct. scrubber. Okay, let's try running that. Where is match not defined? Oh, there we go. That needs to be set there. That needs to be set there. I'm going to try entering this and see whether it works. That's not the correct answer. Okay. Oh, I see the problem. There we go. This is a problem with copy pasta. Okay, now it's not terminating. That is a sign that I have a logic bug. So I think my match here is wrong. Find the least common value and keep only numbers with that bit in that position. So the least common value. So if there are fewer ones, if there are fewer ones, that statement is going to be true. Yep. If there are equally many ones, so I got a value for scrubber, I just did not get a value for, or I got a value for oxygen, but not scrubber. Okay, why is this failing? Hello, Sorcerer Finch. Yeah, part 2 is going fine. I just have been struggling a bit with the bit mashing. So that's where a problem that I have is. So let's just really quickly make sure that I'm getting this far, which I am. Okay, the potential scrubber, I did populate potential scrubber, yep. Yeah, I'm 99% sure this is my problem here, and I just need to think about it more carefully. Find out whether what I suspect is happening is, yep, okay, there are no candidates. Oops, that happened really fast. So if there are no candidates, I want to immediately exit. Just want to immediately return. Yep, there are usually bugs. Okay, so I go from 1,000 candidates to 482 to 1463 and then 0. So why do I go to 0 candidates? Least common value, keep only numbers with that in the position. Oh, there's only one number. Yeah, okay, so I have a problem. That's fascinating. That logic seemed to work fine above. Just double check that I'm doing this correctly. Looking at the indices, I'm looking at that in the position. It's already decomposed into whether it's a 1 or not. Okay. Well, let's go ahead and run on the simple input. Okay, so that one does return. And granted, it returns like something that is off by a bunch of digits, but that one does work. It actually terminates. Wait, it should be impossible for it not to terminate. Because if I'm picking the least common one. Oh, the most common value. But the least common value can also be if 100% of them have the same value. Fizbin suggests using the small input and printing out the list each time through. Okay, so we'll do that. I don't have a parser for this, but that's fine. Print line of data. Okay, so running on the simple input, the scrubber value is fewer 0 bits. Only the 5 numbers that start with a 0. Yep, I've got the 5 numbers that start with a 0. Fewer 2 bits than 3 bits. So therefore we keep everything that has... Okay, so this one was supposed to keep the 1s. Why did it not do that? Right, this is all 12. Then we go correctly do that. Then over here I should be keeping the trues, not the falses. Okay, yep, yeah, I see the logic bug. Okay. The examples only have 5 bits, but since we're going from left to right, it doesn't actually matter. So that's how I'm able to use this to debug. Yeah, okay, so the problem is 1000% range potential scrubber. So that's going to be true. Right, like, so this is going to identify the majority, right? Like, do I need this? Is this my problem? Okay, so now this, yeah, now this one keeps the trues. Okay, false, true, true. Wait, no, that one, that's now busted. Right, so. Okay, we're going to write this out. Wait, integer truncation bit me? Oh, because I was using less than versus greater than. Shit. Okay. Fine. I hate this, but I understand what I have to do. Does that do it? False, true, false, true, false. Yeah, okay. There we go. Thank you. Yep. Thank you for the hint, Fizbin. Yeah, that was absolutely 100% the right hint to give me. Okay, now let's actually grab it, get an answer. If we have an answer, feed it into the algorithm. That's still not correct. Okay. Well, this sucks. Let's see. So this should be. Let me do. Oh. I didn't apply the fix here either. This needs to also be changed here. There we go. And I bet... Yeah, okay. I think I see my problem, except for now I'm probably limited in terms of the number of answers I can submit. It's a little annoying. Okay. Did I leave the 4 in there? Yeah, I did. Okay. That's fine. We'll fix that. It's going to test that against my test answer, but now I feel a little bit more confident about what? All right, we'll try this one. Ah, there, did it. Okay. Ta-da. Yeah. Okay. This was tricksy. This like divide by 2 screwed me up. Okay, got it done. Got it done. Not super proud of taking 40 minutes on it, especially because the suspect the leaderboard or the stats say that, yeah, 4,000 people finished ahead of me. Okay. Today was not my day. While I'm here, thank you for cheering me, Eric. I appreciate it. While I'm here, let's go ahead and clean this up. Basically, what I want to do here is I want to take one copy of this code. Actually, wait, before I do anything, let's commit my working code. That way I don't lose it. Okay, yep, still correct, good. Okay, working code committed, that way I don't lose it. So now let's go ahead and do this refactor. No, I noticed the number is way too small. So that's how I knew I had a problem. All right, so we're going to refactor it this way. So that's going to return an int, and it's going to take a list of these, and then it's going to take a func which says match. And the func is going to take a int and return a bool. No, it just needs to take 2 ints. Okay. So now that I have that, I can basically say oxygen, iterate on data, and scrubber, iterate on data. All right. So this is going to take a ones, and then it's going to take a edits. And we're going to return. This one happens to be using ones. This is 1s times 2 is greater than or equal to it's A. Similarly, return 1s times 2 is less than, is that correct? 1s times 2 is less than candidates. Yep, good. Okay. So now, I can remove all references to this. Still need to do this. Yep, that looks fine. Oh, and then, so here, instead of breaking out of the for loop, I just return ret. Okay. And then drop the reference to oxygen, drop the reference to oxygen, drop the reference to oxygen, and that should do it. Can just delete all of this code here. And now come up here and do that. Okay. So this should run. And it yields a wildly incorrect answer, so I know I have some work to do. What have I... Oh, because I'm not actually using the function, of course. One count candidates. There we go. Okay, same answer, much cleaner. Okay, let's format that up. And let's see. I really wish this puzzle had failed me on this one here by giving me an odd number, or yeah, an odd number of lines, because that probably would have caused me to catch this sooner, but that's okay. All right, I think this code is plentifully, abundantly readable, so let's go ahead and check it in. And I'm going to push this to my website, which is github.com/lizthegray/adventofcode. So that way you can have a look at what I did and see whether you agree or not with the way that I solved it. Yep, there it goes. There's day 3, and you can see the code that we all wrote together. Awesome. Well, thank you for joining me for Advent of Code, and let's go ahead and find someone who is still streaming to go ahead and raid. And I will see you. Hi, Irenes. I literally just finished. I'm sorry. But let's go ahead and find someone else to raid, and I will see you same time tomorrow, about 10 minutes before puzzle unlock.